So, in order to solve this question, we have to first draw a picture. So, we have a spotlight. Let's draw the spotlight right here. And it is 12 meters away from a wall, right? A man who is 2 meters tall, so let's draw that, 2 meters, walks at a speed of 1.6 meters per second. And it's asking how fast this his shadow is decreasing in length when he's 4 meters away from the building. So what this actually makes is two triangles, right? One that is 10 meters in length, the other one is 8 meters in length. Let me erase that. 8 meters in length, and the other one is 12 meters in length. Now we're trying to find out how fast this is changing. So, because these two triangles share an angle, they share two angles. Sorry, this one, which is a 90-degree angle, and this one, they're congruent triangles, right? So the amount by which this changes is the same amount by which this is going to change. So if we know that the top is 12, so basically if in this case we can find out the height of this by saying 12 divided by 8 times times 2, then that would equal our length. And in that same way is how we're going to find how fast the shadow is decreasing. How we're going to do that is we'll set up a formula first, right? So our initial height is 12 divided by x times 2, so it's times 2. And then that equals our shadows. Call that L. And then we need to find the derivative of this. So first I'll simplify it. So 24 over x equals L. And then that can just be rewritten as 24x to the negative 1 equals L. Let's take the derivative of this with respect of time. Okay, so negative 24, x to the negative half, right? Because if you remember, x to the n, the derivative of this is equal to nx n minus 1. And the same way we can take the derivative of this, then times d of x over d of t, and that will equal d of L over d of t. We want to find this right here. We know that d of x over d of t equals 1.6, right? If we remember, we can go up here that the guy is walking at a speed of 1.6 meters per second. So if we go back down here, we can plug in this into our equation and simplify it a bit as well. So in the end, we'll get negative 24 over x squared times 1.6 equals dl over dt. Now we can find out, we know what x is, right? So if we go from the wall, so the distance is 12, right? From the wall, the spotlight is 12 meters. Since it's 4 meters away, this distance has to be 8. We did this by subtracting. So negative 24 over 8 squared times 1.6 equals dl dt. And if we solve this, we get dl dt equals negative 0.6 meters per second. Now, this wouldn't be the answer because if you remember, it's asking how fast is the length of a shadow on the building decreasing. This is the important part. So we're already saying it's decreasing, and we put it negative. It will be a negative decreasing, which is just increasing. So our actual answer is 0.6 meters per second. Then if we were to write it out, it would be the length of the shadow is decreasing at a rate of 0.6 meters per second. This is the answer to this question. Good luck on all your math stuff.